we have a probability question in this case, and it might be quite topical given current situations with the current circumstances, but let's apply our probability theory to this question. So you're told that you have the chance of a student catching a cold in the school holidays is 0.2, nice and simple. 1, what is the probability that 3 particular students all catch a cold during the next holiday? Well, that seems not to be a very well-written question because it depends on the number of students, but we'll assume that there are only 3 students because after all, they said all. So assume only 3 students. Then if they all catch a cold, then it's, well, catch a cold, catch a cold, catch a cold. So the probability of cold, cold, cold is the probability of cold times cold times cold. Formally, it's going to be 3C3, P cubed, Q0, but I mean, very clearly, I think we can see that it's 0.2 or cubed, which is 0.008. So that's going to be the answer to part 1. Part 2, what is the probability that exactly 2 of the 3 particular students catch a cold during the next school holidays? Well, it's a very simple binomial question this time, assuming 3 students only. For 2 students, remember, we don't care about the order. It could be the first and the third, the first and the second and the third. I mean, those are your 3 possibilities, really. If you think of your students as A, B, C, Angela, Bob, and Charlie, say. It could be Angela and Bob that got sick. That's one option. It could be Angela and Charlie that got sick, right? That's your second option. Or you could have Bob and Charlie getting sick, giving you 3 different possibilities. So I think a common mistake might be to just say, okay, we'll take 2 students getting sick, so that's 0.2, and 1 staying well, and that's 0.8. And so I think a lot of students may have done 0.2 all squared times 0.8, giving you an answer of 0.032. But note, that's for a particular combination, e.g. A and B, sick. So what you actually want to do is you want to multiply it by the number of possibilities, which is 3 of them. And so if you multiply this by 3, and that would be 0.096, I should, right? That should have a 0 in front. Now, if we're going to apply binomial probability directly, then the probability of 2 successes or 2 sick would be 3C2, assuming 3 students total, times P, which in this case is 0.2 squared, times 0.8, which will still or should still give you the same answer, which indeed is 0.096. So simple binomial probability question, nice and easy. Just make sure you don't forget the initial coefficient, which many students do. And that's basically how you do the question.